Students, so homework was given in the part of the lecture 2 and I did not cover that in the lecture, and it was done to make you understand the concept of correlation and somehow start teaching you, if you have not already done, how we do the research. So essentially research you are going to do by yourself, and the mentor that you have will only be a guide. So the research you have to do it by yourself. So this was first part of making you understand a little bit of, I'll give you a little flavor of research. So I hope you have learned something from this exercise. What is correlation? So correlation explains the interrelationship between variables within the data, and variance is the degree of spread of your data, and the standard deviation is the dispersion of mean from the data by studying the variance square root, and residual term the residual term or the error term is found within the data set minus the actual minus the expected. So function of x minus, so the function of x minus y of I, and we take this. So this is your residual term. As we discussed in linear regression, that we have some data points better choose a different. So this line tries to best fit our data or best represent our data. The actual points are different. You can see here the actual points are different. So in correlation, what we are trying to do is determine what is the relationship between the predictor variable x and y, and what is the relationship between these two. And you can see here some of the data points, they may be below this line and some will be higher, so they will have a residual or the error, and we are trying to minimize this error. For all these data points, this error should be minimized, right? So in correlation, we are trying to minimize the residual term or the error between the actual and the expected value. We have studied in linear regression the straight line. It can be represented by ymx plus c or a plus bx, another representation notation. X is on the x-axis and y on the y-axis, and x is the independent variable and y is your dependent variable. C is your intercept, the point at which your y intersects with all variables x are 0, and that is the point of y. And m defines your slope. It determines the direction of your data for the best fit line. If the slope is positive, you're going upwards in the data. Slope is negative, you're going downwards in your data to form this line. Okay. And the multiple regression, we have multiple variables. It each individually affects the expected value independently, and there is no interaction among these variables. We keep this in mind for regression. So assumptions that are made for the linear regression. Firstly, that the variables are continuous. There is no relationship between independent variables that I told you, xn and x2. There is no relationship among these two. There should be a linear relationship between the dependent and explanatory or the predicted variables. Y and x should have a linear relationship, and the residual should have a normal distribution. It should be something like this, and have a constant variance. Variance is how much they are spread across, and then residual should be independently distributed, or there should be no auto correlation. Residuals were the terms. So these are actually some values. It could be minus 3.5, sorry, positive 3.5, and then if your data point is here, then it could be minus 6.2. So these are the residual terms. There should be no autocorrelation between these residuals. Okay, I gave this example as a homework where I gave the value of x's 2, 4, 6 and 8, and there was y also given, and then you solve this using a formula that I gave you. First estimate these. At 2, value is 3. At 4, the value is y is 7, and at 6 the value is 5, and so forth. At 8 it is 10. So we first can estimate the square value, then multiplying, then sum them up, because we are going to use them in a correlation formula that is given by this. So the equation was y is equal to a plus bx. A is the intercept, b is your slope. This is the formula for calculating your intercept term, and b is for the slope. So we calculate a, that is 1.5 using the calculations, and b comes out to be 0.95. So the linear equation we have is, because a was 1.5 and b was 0.95, this comes out to be the linear equation. This line best fits our data, means the mean squared error is minimized if we take these values and plot the line. So I wanted to explain this. The target is not just to solve the equation and put in the points and get the equation. The target is also to understand why we are doing this and what information or value we get from this exercise. So we have this plotted points represented by x at 2, 4, 6, 8. These are the actual points that are plotted for given x and y's. And then we found this equation, y equals 1.5 into 0.95. This was our equation. So we put in the value of x. We already know it is at 0 it is 1.5. Then we put the point, these black ones, they are newly these points are newly added up on this line. Just I wanted to give you an overview or just the representation that your predicted points that you use would be on this line. They would exist on this best fit line that you have created. this line. This is y is equal to 1.5 plus 0.9x. So now if we want to find the value of 2.5, it comes out to be this. This is how it's done. Now, one more thing I want to mention over here is that you can see that some of the points, they are below the best fit line and some of them are above. That is how we estimate the residual, calculate the residuals, and then try to minimize the residuals. And then we have, you were also given the homework of calculating the correlation, Pearson correlation coefficient. And for that, you would have found out with Pearson's correlation coefficient, if the value of R is positive, means your X increases with your Y and also your Y increases. So if your X is increasing, Y also increases, and they have a direct relationship. But if your X is increasing and your Y is decreasing, that means it has an indirect relationship. And if your Y does not increase with the X, so we say there is no relationship between the two variables. What does this Pearson correlation coefficient tells us? Okay, we know that positive value, negative value, what it means. Negative means indirect, positive means direct relationship. So in general, not all points will fit this explanation. Not all points not all values of 2, 4, 6, 8 would cause or be represented increasing value of Y. Some of them may decrease, maybe less with increasing X. So the idea of Pearson correlation is to understand the general trend. Either it is moving upwards, it is moving downwards. Of course, there are some other methods, statistical methods, to determine that we can correctly interpret our correlation coefficient, but we won't go into the detail. In general, what we have done is we have tried to understand that there is a relationship between the variables X and Y, and what type of relationship it is determined by your correlation coefficient. And your best fit line will not fit all the data, there will be residuals, and our target is to minimize the residual values. I hope this explanation will help you in understanding the task. So we had two purposes. First, to start the concept of independent research and trying to find the problem and the solution or the direction. And the other was to understand the concept of correlation and how it is linked with linear regression. So if we understand the relationship between variables using correlations, we can do better estimates and better design of our model. So if you have any further questions related to the assignment that was given to you, you can ask me. Yes, so this was the equation. If somebody still doesn't know, this was the equation of correlation. Another representation is this, and then the value is between 1 and -1, and the more closer it is to the extremes values, the more strong the relationship is. A value of 0.82 positive means a highly direct relationship. So in general, with increasing value of X, in general, your Y values are increasing. With age, in general, shoe sizes are increasing, but for some people it may not be so. So those are, you are in general making the relationship between the variables. So if you have any further questions related to the concept of linear regression, correlation, Pearson correlation coefficients, and how and what do they represent, you can ask me via email, or you could ask your TA, of course, and I will try my level best to answer your queries. Thank you.